detail too. Okay, so let me finish up the last portion, which is K. This is an equilibrium constant, and then there is an equilibrium constant based on the concentration. There is an equilibrium constant based on the pressure, and we have this little superscript, well, a subscript on this. This is a concentration based K, and this is pressure. K. And when you say concentration, what I mean is essentially mole per liter. Okay? And the pressure is, I guess the pressure is pressure. You cannot really say. But this is essentially concentration is on molarity. So it's actually, this is not in the textbook. This is a general chem method. You have seen this equation actually. I taught portions of general chemistry before. You guys remember, where's the equation there? They call it delta n. Let me just put it this way. You guys remember? See, the equation looks like this. It was actually it was. I clearly remember. So, for example, if you say, okay, we are just talking about moles of gases. The equation that I just talked about, ammonia production, NH3 gas. There are two of them. And for me, the delta mu, which is the conversion of gas, and you have a 2 minus 1 minus 3, that's a minus 2. So you are going to put this one becomes minus 2 here, and you put, somebody give you the Kc as a constant, and then you put the temperatures and the R, so that's this Kp. The pressure-based equilibrium constant. Remember this? Have you remember seeing that? No. Right? I dare you, if you go back to your class note, it was there before, and it was one of the, I think it was a discussion problem that I usually do in one class. And where this one is coming from, I'm not just going to throw this one at you. So let's think about pressure. So this is PV equal nRT. Everyone knows about this equation. But now what I'm going to do is I'm kind of separating and highlight the same equation into this form. This is a pressure. This is your essentially mole per liter. That's your molarity concentration. And by doing so, I'm already kind of biased because you're already using this R. And obviously, temperature has to be in the unit of Kelvin. But my usual choice is because my volume choice is an L, which is a liter. So therefore, my choices for this is okay, so I put that in, and then this one, essentially, I'll get the pressure in terms of eq'n. So intrinsically, this equation, if I am going to bias myself to use the volume and the number of moles as in this unit as represent the molarity, and that's the. So if you do this, remember now is okay. So that's a Kp. Okay? And this is I think they use a C. Concentration J, J. So they are relating to this term. And then this is what we call Kp, Kc, and this is the same term. So I can put that in. This is your general chemistry way of doing this. It's simple, it's good, and it's a little bit awkward. Okay, and if you're looking at this, what's the unit on this? Does anyone have a wonder what's the unit on this? RT. So R, joule, energy per mole Kelvin, right? And with the temperature, so this is definitely the unit of energy. Right? So this is a unit of energy to the power, like what is the unit of this whole thing, right? It's actually all normalized, so this thing does not have anything has a unit, no unit, no unit. This one is also do not have any unit. So that the only constraint is you must use 0.082 unit of Kelvin, and this one is in terms of Kc in terms of mole per liter, and this is in terms of ATM as a pressure, and then that's an equilibrium constant there. Okay. And but I think that we learned a different method, which is I guess this eq'n way, and this is a little bit more involved. Okay? And this is in our textbook. This equation is true. Okay, there's nothing wrong with this equation. It's just the pressure is you have to use an ATN. Okay, and then this concept is a little awkward. So they have actually can give you this idea. So let's start from this. This is a 1 bar, which is 10 to the 5th Pascal. And the concentration normalization is, I guess, a 1 mole per liter. So let's write it down and let's compare the numbers that I've shown up here with this. Okay. This is a correct one. This is essentially a simplified one. Many people are using it as a shortcut. So what they do is they essentially do not write the normalization pressure, so that your pressure, in this case, you can use any kind of pressure that you want to use. And this one is a 1 bar, and that's the pressure ratio. And then this is the constant that's defined by the reaction. So this is true. When they write this is not actually pressure. Supposed to be, this is a pressure ratio, and what pressure in terms of bar. Okay, so this is not just a pressure, it's actually, sometimes they don't put this one this way. They just do not write this. And they simplify this, but the real concept is this one. Okay. And then now, P for J is V over Nj and RT. And let's say I'm using the notation as a mole, so this is also the notation that I can write. So by doing so, now I'm trying to relate pressure term with the concentration term with an RT there. But by doing so, I'm also being very clear that this is a pressure of any units, and then as long as it's normalized by 1 bar as a standard pressure. Okay, so it's a lot of math, and I think that I want to just show the gist of the equation. Just to practice. So the Kp now J, instead of writing the pressure, is a J RP, and I'm still keeping my pressure as they are. And then this is a mu. So this is the same. And then I am going to extract them out. The portion that is J, J. RT. Okay, so I'll just do that. And this one is related to Kc. It's not Kc, but it is related to Kc. So what that means is this one I can easily say Kc times mu J C naught. That's the one. I can just continue to multiply. Okay. So what I just did it is Kc is also can be defined as J.
Okay, I found this on the web for Hey Siri is also can you defined. Check it out.
I didn't do anything. Okay. Oh my God. What is going on? Okay, so after this we'll have a break. Oh my, it's kind of scary sometimes. Okay, Kc is a concentration. So okay, so then this is my notation is mu J divided by. It's not simple concentration divided by concentration in the 1 moles per liter. That's a normalized concentration. You want to do and to the power of mu J. And so therefore, you got this term top up with multiplying Kc to represent the top portion term only that you saw in here. Okay? So this one is just how you got this one. This way. Okay, so I came a long way to do this. And let me show you the final form. So therefore, really the final form that you want to see here is Kp is Kc times pressure, concentration, RT, delta mu. So this is actually correct term, correct form. And you have, in your general chemistry, you have a shortened version for it. Okay? So this is what you learn in the general chemistry, and this is actually more complete version of it. It has a lot of implications. Okay? The constraint that this one has is, once again, your choice of R requires ATM and the liter, right? And so this one is based on mole per liter, and this one is based on the ATM pressure ratio. Okay? So that's their definition. Whereas this one can be any pressure that you want. Okay? And And this one, once again, it's very clear that this one has no unit because any pressures, any concentration is always normalized by 1 bar and 1 mole per liter. So that's the differences. But now I do have a quite clear definition because the standard pressure is 1 bar and that's the 10 to the 5th Pascal. And this is 1 per liter. So what I can do is the Kc times so this is a 10 to the 5th Pascal, and that's a 1 mole per liter. So 1 mole per liter means 1,000 mole per cubic meter. Is that right? Okay. So 1 liter you have 1 mole. Thousands big volume, which is 1 cubic meter. So that's times 3, 8.314. So now I can use the joule per mole Kelvin, and the temperature is there, and this. So therefore, you got this equation. Looks like Kp is Kc T over 12. This is the equation 6A. So I think it's not important or necessary for you to even remember this equation. I don't think that it's important for you to memorize this equation. All you remember is depending on how you define the pressure and the concentration, particularly for the gases, concentration means mole per liter, or concentration means actually the pressure itself, and they are defined the choice of your concentration quote unquote unit. Okay? And the Kc value and Kp values are related in this way. And as you Are you sure that you haven't seen this one before? I think your general chemistry is probably delta N. That's what they put it in your. I bet you because I'm involved in the general chemistry too, and they are the equation.